All right, so today's video is about the review for the logs test, which really is going to be a logs quiz for us. We're just going to run through each one of these. So a couple things to keep in mind. You could absolutely work backwards for number one and just type in log of 5 wherever there's an A, and then see which one comes out equivalent to log of 250 on your calculator. That's one way to handle it. The other way to do it would be to expand this so that you're writing it in terms of 5, and because it's common log, 10. So if you can rewrite 250 in terms of 5 and 10, that would be your goal. So if I think about the fact that, let's just take 250 and let's just divide by 5. So that would be 50 times 5. And then I can divide by 5 again. There's going to be 5 times 10. So if I bring this all the way down, that means log of 250 is the same as 5 times 5 times 10. Now you can expand that. So you can do log of 5 plus log of 5 plus log of 10. Each of those is A. And then log of 10, that's going to be 1. So there's your answer. 2A plus 1 right there. All right. For the next one, sticking with that same idea of expanding, I want you to look at it and think about, all right, am I looking at multiplication, division, do I have exponents? So this one has a little bit of everything, but the biggest I see here is I look at a division problem. So when I'm dividing, that's going to expand by using subtraction. So I'm going to have the natural log of what's in the numerator here. So the x squared, and then it's going to be minus the natural log of everything in the denominator. So all of that can go right here. So that's the first thing. Then I would take and say, all right, this I've got an exponent. I want to deal with that. Here I've got a multiplication problem. I want to expand this part out further. So for the exponent, I can drop that in front. So it becomes 2 times natural log of x. Here, because I can split this into 2 separate logs using addition, I would have natural log of y and then plus the natural log of square root of z. But you have to remember you're subtracting all of that. So it'd be minus all of that stuff. All right. So the last things that we can do, square root of z is the same as z to the 1/2 power. So I can rewrite this as z to the 1/2 power. And let me just copy down the rest of it. So last thing, I'm going to do 2 things at once. I'm going to take this exponent and drop it out front, and I'm going to distribute the negative. So I'm going to take that minus sign and distribute it here, distribute it here. So I'm going to have 2 natural log and then minus the natural log of y. That's going to switch to minus, and the 1/2 is going to drop out front, the natural log of z. And how I know I've expanded it as far as it can go is inside each log, there's only one single value. So a single x, single y, single z. There you go. All right, for the next 2, determine the inverses of each. So inverse, we've done this with a lot of different expressions. Means we are going to switch our x and y. So remember that f of x is the same thing as just having a y there. So let's flip-flop the x and the y. So it's going to be x by itself on the left, natural log of 2y, and then minus 1 on the right. And now your goal is to solve for y. So if I want to get this alone, it's now a log equation. I need to get the log part of it by itself so that I can undo the log using exponentiating. So let's add 1 to the other side. So that becomes x plus 1 equals the natural log of 2y. And then remember, natural log is log base e. So you have to use a base of e, and we're going to exponentiate using that base. So I'm going to do e and raise it to everything on the left side. E, raise it to everything on the right side. This part cancels. So I get 2y. and then just equals e. Make sure that x plus 1, that whole expression, is in the exponent now. And then the last part, get y by itself by dividing by 2. So my final answer here is going to be e to the x plus 1 power divided by 2. That would be my F inverse. Keep in mind, there's multiple ways that you could write that. You could write it as 1/2 e to the x plus 1 power, but this is perfectly fine. Same type of thing goes for this next one. So remember that that's just y, and now I'm going to switch my x and y. So x goes on the left, 10 raised to the 3y plus 1, and then all of that minus 5 on the right. All right, so now it's the opposite. It's an exponential equation, which means instead of getting like the log by itself like we did back here, you're going to need to get this base 10 raised to whatever power by itself, which really just means move the 5 out of the way. So let's make it x plus 5, and then equals 10 raised to the 3y plus 1. Now to undo that base of 10, we're going to use log base 10. So I'm going to squeeze it in here. I'm going to go log base 10 of the left side, do log base 10 of the right-hand side. When I do that, log base 10 of 10 cancels, and I'm just left with 3y plus 1. Over here, I'm going to have log of x plus 5, and you can carry the base 10 or not, but make sure you have the parenthesis because it's not just log of x. I want that whole thing that I'm taking the log of. And then the last parts of this, to get y alone, subtract 1, divide by 3. So I'm going to have, as a final answer, log base 10 of x plus 5. Out on the end, we'll have a minus 1, and then we're going to have all of that being divided by 3. That is the inverse equation here. But what should make sense, if you start with a log, the inverse is an exponential. If you start with an exponential function, the inverse is a log. That's the connection. Oops, I'm a little off the page there. There we go. All right, last two. I'm just going to walk you through those ones. Keep in mind, probably best to try all these on your own and then just watch through and make sure that you're doing everything okay. So with this, solve the following algebraically. You can, of course, you can check it using your graphing calculator, but that is code for I should see a log here, and I want to see the undoing of the log over here. So for the first one, before I can bring logs into it, I need to get the 5 to the x all by itself. So add the 9 on over. So that would be 108, and then divide the 3 out. So when you do 108 over 3, that'll give you 36. All right, the base is 5, so that means we're going to use log base 5 on both sides. So when I squeeze in here, log base 5 of 5 to the x, log base 5 of 36. If you could fit it here, go ahead. I just didn't want to have to smush it in. That cancels, and now I go to the calculator with this part of it. So on my calculator, if you've got the log base button, go to math, and then up to log base, and then you can do log base 5 of 36. If you don't, then you type it in as log of 36 and then divided by log of 5, which honestly is just as quick. So 2.226, so to the nearest hundredth, we would have 2.23. There's your first one. Notice how the word log shows up in the solution. You can't go from here to this answer and say that you did it algebraically if I don't see the log showing up in there. Part B of it. This one starts with a log. So in this case, we're going to do the opposite. We're going to exponentiate, which I always think sounds like a fake word, but sure. We're going to exponentiate on both sides. So the log's already by itself. So let's actually go right to it. So the base is the x plus 4. So we're going to use the base of x plus 4 on both sides. So on the left, let's do x plus 4, all of that raised to the log. On the right, you're going to do x plus 4 and then raise it to the 2. That cancels, and you're left with 17x minus 4. On the right, I'm going to rewrite it again just to make sure we're understanding what this is. This is x plus 4 raised to the second power, which means I need to square this thing. Box method, if that's what you're comfortable with. FOIL is your other option. So multiply it out by itself. So x squared, 4x, and 16, which means we're going to have x squared plus 8x plus 16, and then 17x minus 4 on the other side. Now you have a quadratic. It's no longer a log equation. You're just solving this. So subtract the 17x over, add the 4 over, and you get x squared. This is going to give us minus 9x plus 20. And then if we do a little add, multiply. Now this should be pretty darn simple. X and x, double negative, so that we can add to negative 9, but multiply to positive 20. So we get positive 4, we get positive 5. You want to make sure to still check those answers. So all I mean by that, make sure it's not going to make anything up here negative, and you should pretty much be golden. So if I put 4 in the base, 4 plus 4 is 8, that's fine. If I put 4 here, 17 times 4 is pretty big. So when you subtract 4 from it, you're good. Same argument can be made for the 5. The base would be 9, which is fine. Plug in a 5 here. That's definitely going to be positive. If you want to be absolutely certain, actually type that value into your calculator. Make sure it comes out as 2. Otherwise, as long as we didn't make any algebraic errors, we can assume that we are going to give answers that work and we're good to go. All right, I hope that helped. I will send you the email with the quiz Friday morning. If you have any questions, please reach out to me. I'm happy to set up one-on-one question sessions if you want to ask a few things and don't want to have to do it in a big group.